Hello everyone, welcome to DCC NIT Agartala. Myself Tejas, and today I'll be discussing the fourth problem from LeetCode Biweekly Contest 100. The name of this problem is minimum time to repair cars. The question states that we are given an integer array ranks representing the ranks of some mechanics. Ranks I is the rank of the ith mechanic. A mechanic with a rank R can repair n cars in R into n square minutes. We are also given the number of cars. Okay, the cars means the number of cars that needs to be repaired. Return the minimum time taken to repair all the cars. Also, a very important point is that all the mechanics can repair the car simultaneously. Now, suppose we assume a time t. Suppose we assume a time t, and currently, and suppose we are considering a mechanic which has rank R, and we know that in time t, or to repair n cars, it will need r into n square time. So our t is equals to r into n square. Now if we have assumed our t and we know the r, so the number of cars that he can repair at this time t, within this time t, will be t by r, or root over t by r. And since all the mechanics can repair cars simultaneously, different cars simultaneously, suppose we have another so suppose in the same time another matrix with whose rank is r, with, and the number of cars that this mechanic can repair in the time t is suppose m. So this will become m square r. It's not r into r, but it's r. Okay, so in this case m, that is the number of cars for the second mechanic, will again become t by rr, root over t by rr. So suppose we have n mechanics, so we have number of cars for the first mechanic is n, for the second mechanic is m, and the for the third it's suppose o, and then p, q, something like that. So the total number of cars that can be repaired by all the mechanics all together will be summation of all these, that is n plus m plus dot 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 other cars. So if we have this number of cars and we have our target is equals to, target is equals to cars. So if this number of cars, that is the summation, if the summation is less than cars, that is the number of cars that we need to repair, we can infer that the time that we need to repair all the cars, the minimum time that we need to repair all the cars will be greater than this time t that we were considering in the previous case. And if the summation is more than cars, then we can infer that the time taken will be the time that the minimum time will be less than the time that we previously considered. So this type of questions can be easily solved using binary search. Now let's see how we will implement this. So first we'll initialize the range. So low equals to 0 long and high equals to, so the cars, the maximum number of cars can be 10 to the power 6, and the maximum rank can be 100. So, and in t time, a mechanic can repair r into n square. Okay, in t minutes, for n cars, a mechanic will require r into n square minutes. So r into n square in the worst case will be 10 to the power 12 into 100. So long of 10 to the power 14. Now while our low is less than high, we'll have a mid value. Okay, this will be our time t, low plus high minus low by 2. So in this time, the total cars, let's make it long, in this time the number of cars will be that can be repaired by all the mechanics will increment the number of cars in this total car. So I'll run a loop in the ranks, plus will be equal to our mid, that is the time, by rank, that is this element. Also the total number of cars is n square equals to time by rank. So this will be math dot square root We'll take the square root of this, and this will be a long. Now if our total cars is more than or equals to our cars, then our high will update our high to mid, and else we'll update our low to mid plus 1, and we'll simply return the low. Now let's see if this works. It's giving a okay, so int mid, it will be long mid. Okay, so it's accepted. So thank you guys.